Hello everyone, welcome to Building the reInvent app with Amazon Location Service. My name is Fernando Rocha. I'm a Senior Specialist Solution Architect for Front-End and Mobile Technologies on AWS. I've spent all of my career focusing on mobile app development or backends that support mobile apps. A good chunk of my career was also spent on applications that rely on geospatial data. And that's why I'm here today. I want to share with you the journey that the reInvent transportation team took to overcome the usual challenges that adding a location-based provider into your application usually brings. And I want to really point out the reasons why they chose Amazon Location Service for it. First, I need to introduce the service to you, which you may or may not know, since the service was just released in GA in June of this year. Then, we'll talk about how the application was built and the location-based logical flows that it is using to leverage geospatial data to support their users' needs. After that, I'll show you some resources you can use yourself to add the same functionalities into your own applications, by not only giving you an overview of the features the service offers, but the strongest suits that I believe it brings to application development. Let's start this conversation by talking about a very common process that people use to onboard location data into their applications. If you had an application that had to rely on this type of data, this process is probably not new to you. Only the order of some of the steps that may change. First, you need to understand what type of location requirements your application needs. You need to geocode, you need route, tracking, maps. After all of this is decided, you need to go to the market and find a data provider that covers all of your requirements. That's the easy part, and sometimes that's the fun part. Depending on where you work, a procurement and sourcing process is also needed, and that's where things start to get complicated. Meaning because this process will rarely depend on you or your team. And hey, I'm only making assumptions here based on my past experiences, but I've seen a lot of people face the same issues as well. But maybe you're lucky and this is easier for you. After that, pricing negotiations start. Enterprise pricing, private pricing, request-based usage pricing, you cannot escape from this. After all, you're looking for the best service for the best price. Your security team will also want to do an assessment as well, and this can take a long time to be completed. Again, super useful. Security is job zero here, so you cannot skip this step. However, so far, none of the steps are adding any value to your solution. Once security is done, time to set up your infrastructure to host the solution. Well, put everything together in your data center to deploy the service provider software. After this is done, or if you're using a cloud-based integration, integration starts. You need to connect your application to the location-based data provider somehow. Is it a database connection, APIs, WebSockets? After this is done, deploy the solution into your test or staging environment so you can run all the tests that are needed to validate data. Check if the information is good enough, if it fits your requirements. You have a global footprint? If you do, it's going to be hard to find a single provider that has amazing data all over the world. Awesome, you're done with your testing. Is the data not good enough? Start over. I mean, this paints a very bad scenario, but you'd be surprised how often this happens to real industries. So I hope I've painted a horrible picture to you. Because I want to present to you a solution that may facilitate a lot of the hurdles that you need to jump to onboard the location data provider to your application. Now, what is Amazon Location Service? Let's take the obvious part out of the way. It is a location-based service that provides geospatial features that you can integrate into your applications. It is a fully managed service as well, so you don't need to worry about managing the underlying infrastructure that supports it. OS updates, antiviruses, security updates, this is all managed by AWS. It is also completely serverless, meaning that you don't need to create or host infrastructure that will support it. That's all managed by AWS as well. AWS also scales the service to your needs and makes it sure that it's operational and has seamless integrations with other AWS services as well. All you need is an AWS account to make this happen. The service is also available globally, which improves the latency required to access its data. But it also provides geospatial data that is global. So you have a global footprint, you're covered. And these are the features that Amazon Location provides to you today. With Maps, you can add visualization layer into your application. Places will give you geocoding and reverse geocoding capabilities. Routes will give you information on how to get you from point A to point B. Trackers will let you send and retrieve real-time or batch geolocation information for vehicles, mobile devices, and any other asset that can provide their location information. And geofences, finally, provide a way for you to store areas of interest that can generate events whenever assets enter or exit their polygons. And if your application is using these features, where is the data coming from? AWS decided that the data that is supporting maps, places, and routes should not be managed by us. We already have partners that have years of well-established relationships in the geospatial market that have been serving quality data at scale for millions of customers for a very long time. For this reason, AWS decided to leverage Esri and HERE Technologies capabilities to serve our customers. Application developers trust Esri and HERE's data to route millions of vehicles and power hundreds of thousands of mobile applications and websites today. Esri provides AWS customers access to various styles of map tiles, geocoding capabilities, reverse geocoding capabilities, and street-level address data. Today, Esri's technology is deployed in more than 350,000 organizations, including 90 of the Fortune 100 companies. HERE Technology provides AWS customers access to base maps, geocoding, reverse geocoding, and street-level address data as well. Maps provided by HERE are constantly validated based on an average of 5 million daily updates to deliver over 900 mapping attributes and maintain accurate information. And what do you get from this? First of all, you can rely on trusted AWS partners to provide your data. They provide global coverage to your application. And if you have a global footprint, you probably realize or will very quickly realize that a provider that works really well in the United States may not work too well in India or Brazil. With Esri and HERE, you can choose the best provider for different areas of the world. You get one single API with one single structure, independent of provider. This makes it very easier to move from one provider to another if needed, with no code changes. And you also get one single price structure, independent of the provider you choose, facilitating your billing process quite a lot. And this is how Amazon Location Service facilitates the development of location-based applications. By having an AWS account, you can create the resource you need without the need to onboard new vendors or set up new credentials. Just select what you want to use and start integrating. You also get simplified global coverage powered by Esri and HERE Technologies. Integrating is also made simple. Amazon Location Service integrates with many other AWS offerings to facilitate authentication and authorization, monitoring and operationalization, event-driven architectures, and front-end and back-end development solutions. It also lowers the cost of experimentation. You can benefit from a free tier, affordable request-based usage pricing plans, and you can start and stop using the service whenever you need. There are no penalties involved in this position. Now, let's talk about the application that we'll be discussing for the remainder of the session now, the re:Invent mobile app. Either if this is your first re:Invent or not, you already know that this is the biggest cloud conference in the world. We have attendees coming from all parts of the globe, and the hotels are packed with people like you who want to learn more about AWS, maybe start new partnerships, or just went to Vegas to enjoy my company. With more than 1,000 sessions, stands, and events spread across the city, it is very easy for attendees to get lost during re:Invent and risk missing out on sessions that they came a long way to be a part of. AWS, because of that, wants to ensure that guests and partners get the best possible experience at the event, and that they are able to tailor an event program which suits their needs. For this year, Amazon provided an app as a one-stop shop for event-related information. The main goal of the app is to direct people to the right places so they don't waste time trying to find their way around. We're expecting 20,000 customers that will be attending sessions in 4 different venues. We have 125 shuttles who will facilitate the transportation between 25 predetermined routes, making sure that participants get to their sessions in time. And how is the app helping you? It is answering these questions that are posted here. But how are they building this? Well, let's start by answering the first 2 questions. Amazon Location Service provides many different features to users, but we always need to start with maps. Maps are usually the starting point to many applications that rely on geospatial data. They provide the ability to visualize the location information that is important to you, that being your hotel, the venue where your session is, a restaurant, the path of a route you need to take, and many other use cases. Amazon Location provides multiple different map styles, with simple APIs to use, where you can leverage very popular front-end rendering libraries like MapLibre to create amazing and highly customizable visual experience and representations of your geospatial data. A map will provide you the visual information you need to find your current location and route you to the location you want to go, in this particular case of the app. Another crucial feature provided by Amazon Location Service that will help you get to places is routes. Routes answers a simple question: how do I get from point A to point B, and how long this is going to take? However, providing an origin and a destination is usually not enough to get a clear picture of a path you need to take, most times. You could be driving a car, a truck, or be walking. You may want to plan ahead and check how the route is going to look like at 6 a.m. tomorrow, or maybe you want to leave right now. What about details of the route? Can I get the path that I need to take? All of this is provided by routes in Amazon Location. You can calculate time and distance between 2 points, adding up to 23 stops in the route. You get a polyline that you can plot on top of a map to get a visual representation of the route to take and details about every single leg of the trip. You can calculate the route for different modes, now or in the future, and add details to the trip for cars and trucks too. All these details help you get the best route that fits your needs. And this is the logical flow of the process. On the left, you have the reInvent mobile app, making a request to Amazon Location Service to collect the route information that is needed. You set a departure time, which can be now, and provide a current position as the origin. Your destination is the hotel or venue you want to get to. Your travel mode can be set to walk-in if you feel like taking a stroll, for example. This request is then sent to Amazon Location Service, which will calculate your response with the help of one of our data providers, and return a detailed overview of your trip with distance, duration, and a polyline to be plotted on top of the map. Now you know how to get to the right place. Let's look now on how Amazon Location Service is helping you and the transportation team understand shuttle movement, performance, and how they can make decisions quickly based on this information. When we talk about understanding where an asset like a shuttle is, we're talking about tracking. Every shuttle that the transportation team made available to you has a mobile device capturing its current location and sending it back to AWS for processing. That's how the app provides to you information about a shuttle arrival and movement. From a management perspective, this is also very valuable because you could get an overview of all of your shuttles and how they are performing. Amazon Location provides tracking capabilities to our customers, giving them the ability to store location updates for devices and assets, querying for actual positions and historical locations up to 30 days. It also provides the capability of filter bogus positions based on poor satellite connectivity or issues with GPS tracking. Because of that, Amazon Location Service introduced position filtering as a new option to trackers that enables cost reduction and reduces jitter from inaccurate devices' location updates, along with the addition of 2 position filtering options for this. The first one, distance-based filtering, ignores location updates wherein devices have moved less than 30 meters. When utilizing this distance-based position filtering, Amazon Location will not evaluate these updates against geofences, nor will it store the updates. If you're utilizing specialized hardware with better accuracy, for example, precision vehicle tracking equipment, in order to calculate device positions, then maybe you should choose the other method, time-based filtering. That's the default one. In time-based filtering, every location update is evaluated against linked geofence collections, but not every location update is stored. If your update frequency is more often than 30 seconds, then only 1 update per 30 seconds is stored for each unique device. PostNL, the #1 e-commerce and postal logistics provider in the Netherlands, for example, is using trackers to track the movement of 250,000 unique loading devices, known as RORO cages, which are a critical component of their logistical network. So how this is actually working on the reInvent app? Every 10 seconds, each shuttle sends its current position using the Batch Update Position API. With the Location SDK, you can even configure how often you are collecting the location and how often you should send it as well. The payload is quite simple, as you can see. Mainly, you need a device ID to identify the vehicle, the location in longitude and latitude format, and the time associated to the capture. You can send 1 or multiple positions at a time. These positions are stored in the tracker and are later processed for multiple purposes that I'll share in the next slides. But privacy is a big deal. We need to talk about that. Note that 51% of US marketers expect the budget allocation for location-based services to increase. On the other hand, 71% of consumers are less willing to share physical location to mobile apps compared to other forms of personal data, such as mobile phone numbers or maybe responses to a survey. Let's take a step back and talk a little bit about how Amazon Location handles security and privacy. Tracking and geofencing information, for example, never leaves your AWS account, unless you choose to do so. Requests for maps, places, and routes, since they rely on our partners Esri and Here, are anonymized, so they will never know who is making a particular request at that time. The service also has very strict licensing terms that do not allow Amazon or our partners to use your data for marketing or sell it to other customers. The service also uses service-managed keys to encrypt your data at rest and in transit, but you can choose to use your own keys for encryption as well. GeoGuard, for example, one of our customers, focuses on geolocation-based security. They also do location fraud detection and the protection of digital content. They value Amazon Location's commitment to data privacy and security. This commitment is important to businesses who hold large amounts of personal data or proprietary data. That said, let's talk about a very important piece of the solution. How can we guarantee that the mobile apps have access to Amazon Location features in a controlled environment? Amazon Cognito provides solutions to control access to many AWS resources from your app. You can define roles and map users to different roles so your apps can access only the resources that are authorized for each user. You can use attributes from identity providers in AWS Identity and Access Management permission policies. So you can control access to resources to users who meet specific attribute conditions. The app leverages Amazon Cognito to authenticate users and shuttles. Cognito also relies on AWS IAM to validate fine-grained policies that authorize access to all of the Amazon Location Service APIs. This helps guarantee best practices like least privilege access to Amazon Location's features. Now that we have covered security, another main feature that this solution possesses is the shuttle administration portion. Knowing where a shuttle currently is helps the reInvent transportation team understand how they are performing. if they are on time, and if more are needed to be deployed to help you get to places. By calling the list device position APIs, the administration app collects the current position of all shuttles and plots them into a map, also provided by Amazon Location, by the way. The response payload contains the device IDs, their shuttles, their positions, and the timestamp associated to their locations. This type of information is extremely useful in a control room, where you can realize in real time how to get information of your fleet. By understanding their historical paths, you can even make informed decisions on how to better the route of your shuttles and understand if you need to add new vehicles or even remove them if they're not being used properly. Another great feature provided by this app is the information about how far a shuttle is from a determined bus stop. When a customer wants to know if a bus is arriving, they make a request to Amazon Location, requesting the shuttle's position and understanding everything with it. With this, the service calculates the route between the bus stop and the shuttle. In your application, you can choose to calculate the route for cars, trucks, or walking as well. You can pick a departure time and choose multiple options for trucks and cars, like avoid tolls or set dimensions to trucks too. You can also set units like kilometers or miles to get the distance. That facilitates localization for different areas of the globe. For this use case, the service returns the duration in seconds, so you always know when the next shuttle is arriving. What if I want to send an alert to my customer when a shuttle is arriving at a determined place? For that, you can leverage geofence collections. Geofences are best used in the solution to identify areas that buses use to pick up and drop off passengers. And that's what geofences are, areas of interest where actions related to geolocations can occur. Geofence collections on Amazon Location provide the capabilities of detecting enter and exit events on these areas. By providing the current position of a shuttle, these collections are automatically evaluated against all of the geofences that they have stored. Once it is detected that a shuttle has entered one of these geofences, an enter event is posted on Amazon EventBridge for further processing. The same process applies when a shuttle leaves an area, generating an exit event. The location evaluation can happen via an API call or by linking trackers and geofencing collections together. That will free you from calling the API directly, and this is great from an automation and integration standpoint. But how are these geofences created? Well, multiple ways. In this case, the reInvent transportation team has a CSV file that contains all of the polygons that they have, representing areas where the shuttles stop to pick up passengers. An automated process was created where they dropped the CSV file into Amazon S3, one of our object storage solutions. This will trigger a Lambda function that reads the file and calls the batch push geofences API, storing each geofence with an ID and the polygon associated to it on Amazon Location Service. Okay, so now we know how these geofences are being stored. What happens next? We know that the shuttle sends an updated position to Amazon Location every 10 seconds, right? What we'll see now is how these positions are being automatically evaluated against these geofences that represent stop points. Once the data arrives on the tracker, since it's linked to a geofence collection, that position is automatically evaluated against all shuttle stops that were added during the process explained in our previous slide. If it is detected that a shuttle has entered or exited an area of interest, an event is sent to Amazon EventBridge containing the shuttle ID, the geofence that was breached, and the event itself, either enter or exit. It also sends a timestamp of when the event happened. This is great for performance analysis because now you can determine an entry and exit time for the shuttle stop. That gives you a good visibility of how long it is taking for a bus to perform its onboarding process. This event is then routed to a Lambda function that will process the event and store it on Amazon DynamoDB, one of our NoSQL offerings. You can also leverage multiple geofences, in this case, to notify different interested parties of location events. In this case, we have a larger red geofence that could represent the near arrival of a shuttle. That can notify an operator that it is time to organize a line of attendees that will enter the buses. That will maximize efficiency if you think about it. Once the bus enters the blue area, you can start tracking how long it is taking to onboard everyone, giving you a valuable data for process improvement. One customer benefiting from Amazon Locations geofences collections is Command Alcon. They needed to have a geofence solution built, released, and approved by a State Department of Transportation within 4 weeks. The urgency was driven by a new state regulation to provide touchless and electronic proof of delivery of construction materials to paving project sites. They realized that they could implement the necessary functionality in real time using trackers and geofences, and were able to achieve the solution in 2 weeks. Another great feature provided by Amazon Location is Places. With Places, you can search for points of interest like the Venetian or the Statue of Liberty. You can put a marker on your map and then calculate the route to take to that location. You can also transform addresses into geolocations by geocoding a string, and do the reverse process by reverse geocoding a location into a human-readable address. These APIs can be used for address validation, normalization, and to enrich your database as well with geospatial data. You can use the Suggestions API for an autocomplete feature if you have a front-end application. Places also lets you store the results of your queries on your own databases or any storage solution you may have. Now, where's the Eiffel Tower? By geocoding this simple string, you can get a very detailed response of not only where it is geopositioned, but also the full address if needed. Note that if you get a full label containing details of the address and also parameters that separate each of the address's response. And what is this place that I'm currently in? This is the reverse process. Now we're reverse geocoding a position to determine what is that place. In this case, we're passing the Eiffel Tower's latitude and longitude and receiving a full address back. Mitsubishi, one of our customers, is using Amazon Location for visualization and analysis of geolocation data collected by mobile applications that are used by tourists. This makes it possible to easily utilize large amounts of difficult-to-handle geospatial data on applications while managing the privacy and security issues. As a result, they're able to verify the effectiveness of the content to direct tourists to the attractions by visualizing behavior data according to the attributes of tourists and by extracting the stay time and the specific stops from GPS data. Okay, so now I've talked all about the features that Amazon Location has. How can you get started? Amazon Location has front-end SDKs for Android, iOS, JavaScript, and back-end SDKs for C++, Go, Java, JavaScript, .NET, Node.js, PHP, Python, and Ruby. You can also use the REST APIs provided by AWS to manage and use the service. Also, you can create resources using the AWS console, the CLI, the APIs, and the SDKs as well. Another service that can facilitate your location-based solution development is AWS Amplify. Amplify is a front-end development tool that helps developers create secure, reliable, scalable, and operational backends in minutes. By using the Amplify CLI or the admin UI, you can configure your backends fast by using any of the categories listed here. The service also provides libraries and UI components to facilitate the communication between your front-end and your Amplify created backend. The categories currently supported are authentication, data storage, API in GraphQL and REST, functions, analytics, PubSub, predictions, interactions, notifications, and now Geo. Amplify Geo lets developers add mapping and location feature capabilities to their web and mobile apps, all powered by Amazon Location Service. It reduces the development time by using a low-code approach to front-end development, providing an opinionated APIs to communicate with Amazon Location and all of its resources. The service is now generally available in 9 regions for JavaScript and in developer preview for iOS and Android. This is an example on how you can add a map to a web application by using Amplify. The service leverages an open source renderer called MapLibre to render maps into your applications with tiles provided by Amazon Location Service partners Esri or Here. And get started now with Amplify Geo by going to amplify.aws or go to the location URL to learn more about Amazon Location and its capabilities. See step-by-step guides, sample apps, and architectural references. I hope to see your own applications very soon. And that's all I have for you today. Thank you so much for joining and learning a little bit more about this journey. Thank you.